Okay, the next one is covalent radii, which is on page number 75 of your book. Now, what is a covalent radius or covalent radii? One half of the distance between the nuclei of two similar atoms of the same molecule containing a single covalent bond is called covalent radius. Okay, first we have to know covalent bond. What is a covalent bond? When an atom share their electrons, means that when an atom share their electron with the other atom, it is called covalent bond. Means they do not lose their electron, they just share their electrons, and this is called covalent bond. Single covalent bonds mean when an atom share only one electron, means single electron, not more than one electron. It is called single covalent bond, right? So this is the definition. Okay, similar atoms mean एक जैसे atoms. Okay, one half of the distance between the nuclei. Okay, we have to know what is meant by one half of the distance. Here I have a structure of two similar atoms. We can say that this is the two similar atoms, that is hydrogen. In the center, nucleus is present, so distance between the nucleus. One half of the distance between the nuclei of two similar atoms. As these are the two similar atoms, so we have to take the one half. We know that distance between the nucleus and valence shell, it is called atomic radius, but now it is covalently bonded, right? This is a line that it shows the bond between the atom. They are covalently bonded. Now we have to take the distance one half distance, that is from this point to this point, from nucleus to this point, and it is called covalent radius, right? This is the structure of hydrogen, two similar atom, and this is, we can say that from this point to from this point, we call it covalent radius. And covalent radius of hydrogen is 37.7 picometers, right? Here the distance between nuclei to nuclei is 75.4 picometer, mean from this point to this point there is a distance of 75.4 picometers. But if we take the half of this, mean when we divide 75.4 picometer to 2, we divide this because we have to take one half distance, mean from this point to this point. So for one half we have to divide this value by 2, so we get 37.7 picometer, and this is the one half of the distance between the nuclei of two similar atoms of the same molecule, and it contains a single covalent bond. Now you can easily understand this definition. One half of the distance between the nuclei, right? These are the nuclei, so we have to take the half distance of nuclei. So this is the half distance between the nuclei of two similar atoms. For example, this is the hydrogen and this is also hydrogen, two similar atoms of the same molecule. When two atoms combine, H plus H, it form H2, and H2 is a molecule, right, of the same molecule and containing a single covalent bond. It is called covalent radius, right? I hope you understand that. Here is a diagram. This is the distance. This is a distance between the nuclei that are represented by D, and this is the A point and this is the B point. This is the A point and this is the B point from nuclei to nuclei. So for differentiate, we have to take A dash and B dash, and this is the one half of the distance from A to A dash and from B to B dash. These are the 1/2 of the difference, mean from A to A dash and from B to B dash. This is the 1/2 of the distance between the nuclei, and it is the radius, mean from nucleus to outermost shell. The distance is called radius, and it is the radius. And if we take nuclei to nuclei half distance, 1/2 distance, it is called covalent radius, and this is the nucleus, right? Okay, on page number 73 of your book, there are some examples of halogens, that how we can measure 1/2 of the distance, or we can say covalent radius. So here is a structure of F2, that is fluorine. F2. Intermolecular distance, it is a bond length, mean from this point to from this point. This is the bond length between two similar atoms, that is 143 picometer. This is the bond length. Now if we have to find the covalent radius of fluorine, so we do here 143, we have to divide 143 on 2. So when we divide this on when we divide 142 on 2, so we get covalent radius of 72 picometer, and that 72 is the 1/2 of the distance between the nuclei. Here is another example, that is of Cl2. So from this point to this point, it is called intermolecular distance or bond length, which is 199 picometer. So if we have to find the covalent radius of Cl2, we simply divide 199 on 2. When we divide this, we got the covalent radius of 100 picometer. Right, so this is the covalent radius. How we can find covalent radius? Okay, covalent radius is radius of the covalent compounds, and it can be measured by X-rays. Okay, on page number 73, you have two more examples of bromine and iodine, where bond length are given, and you have to find the covalent radius by simply you have to divide D on 2. D is the distance between the nuclei. When you divide D, that is distance or bond length, on 2, we simply find the covalent radius of the atoms, right? Okay girls, I hope you understand this lecture. The picture of this lecture will share in your group. You have to write that work on your neat copies. Right, with proper presentation, with date, margin line, ending line, with each and everything. Okay, thank you girls. Allah Hafiz.